Is there any doubt from the last class?
No, sir.
Okay, no doubt. So I had given you homework. Have you done it? This is from a exercise basically.
Yes, yes.
Okay, is there any doubt in homework, Harsha?
No, sir.
Okay, that means you all have done all the homework, right? Okay. So I'm going to give you a question and then we will move to next part. And Harsha, you have you done all the question?
Sir?
Have you done all the homework? Yes or no?
Sir, just 2 minutes.
Okay. In the given diagram, I'm going to draw a diagram in which all the resistances are given and a 12-volt battery is also connected. We need to calculate equivalent resistance, that means total resistance in the circuit, and total current flowing in the circuit.
Sir, I didn't complete the homework. I'll complete it today.
Okay, and please send it to me.
Okay, sir.
This is 12-volt battery and this is the direction of current. I'm going to write the value of this. This is R1, this is R2, this is R3, this is R4, this is R5. Please do this question. Take your time, but do it correctly. Wait. If you have any doubt, please ask me. I'm expecting that everyone can do this question. Abdullah, can you solve it?
No, sir. A little bit hard.
Okay. So I'm going to explain it. Just concentrate here. It's very easy. Uh, in the given diagram, you can see R1, R2, R3, and R4 and R5 are given. The resistors value is given. R1 as 10 ohm. Just answer me, Abdullah. R1 and R2 are in series or parallel? Is
Yes, sir.
R1 and R1 and R2 are in series combination or parallel combination?
Parallel.
Parallel. So just solve this R1 and R2 separately. Just like I'm going to do it, R1 upon R equivalent will be equal to 1 by R1 plus 1 by R2. And in the same way, you can put the value 1 upon 10 plus R2 as a value 1 by 40. Now take the LCM. 1 upon R equivalent will be equal to, if you are going to take LCM, it will be 40. And here it will be 4 plus 1. And now you can solve it. 1 upon R equivalent will be equal to basically 5 by 40. But we need, this is the value of 1 upon R equivalent. We need to find the value of R equivalent. That will be equal to reciprocal. So 40 by 5. And it will be equal to R equivalent will be equal to 8 ohm. Is that clear?
Okay. Okay, sir.
Now we are going to find this in separate way. R3, R4 and R5. R3, R4, R5 are in series or parallel? Answer me. Abdullah, R3, R4, R5 are in series or in parallel combination?
Yes, sir.
The second scenario is in parallel or series?
Series.
Is it in series? Harsha?
Sir, parallel.
It is in parallel. You can see if current is coming from this way, it will be divided into three parts, this, so it is in parallel. So we are going to again apply the formula for this section, R3, R4, R5. You can see 1 upon R dash equivalent will be equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5.
Okay. Okay, sir.
Now see, 1 upon R dash equivalent will be equal to R3 has a value. What is the value of R3? That is 30. R4 has a value 20 and R5 has a value 60. Can anyone tell me the LCM of 20, 30 and 60?
60.
60. It will be 60. Now 32 is 60, then it will be 2. 23 is 60, 61 is 60. So 1 upon R dash equivalent will be equal to 2 plus 3, 5 plus 1, 6. 6 by 60. And if you are going to take the value of R dash equivalent, it will be equal to 60 by 6, which means 10 ohm. Is that clear? We just calculated the separate equivalent resistance. Now see how it will look after this. This will be looking like this. There was a switch, and now here was 2 in parallel. Now it will become 1 and it will be like this. And here was also in parallel combination and it will look like this. Now you can see this is 10 ohm and this is 8 ohm. Now what is the combination? Series or parallel?
Series.
Series. So now you are going to find the R equivalent. So R double dash equivalent, because I already took it, R equivalent, R dash equivalent, and it will be equal to 8 plus 10. That will be equal to 18 ohm. Is that clear?
Yes, sir.
This
Yes,
is
sir.
the first part, A part. Now we are going to calculate B part, and B part, what we need to calculate in B part? Current flowing, total current flowing through the circuit. Now we will apply Ohm's law. V is equal to IR, I is equal to V upon R. Since we are going to find or calculate total current, so we are going to put the value of R equivalent, total resistance. So since V is constant, that is 12, and R equivalent, that we just calculated as 18. So it will be cancelled by 3 4 ja and 3 6 ja, or 2 3 ja 6, 2 2 ja 4, and it will be equal to almost what, 0.666 ampere, or you can also write 0.67 ampere. Is that clear, Harsha? We need to do a lot of questions on this in this chapter
Okay,
or
sir.
in this topic. So I'm going to slide it up. Please write it carefully. And if you have any doubt, have you written the question?
Yes, sir.
Okay. I'm going to show this part and please write it carefully. We have to do a lot of question on this chapter in this chapter. So I'm going to uh, give you some more questions to practice. Done with this?
Yes, sir.
Okay. Abdullah, are you done with this all?
Yes, sir.
Okay. Going to give you another question. This chapter has a very less formula, like I already taught you that I is equal to Q by T. So you can also write Q is equal to I into T. This two formula, or you can say one formula. Again, we had a formula, rho is equal to, sorry, R is equal to, resistance is equal to rho L by A. Or you can also write rho is equal to R A upon L. This is also one formula, but we can make two with the same formula. Again, next formula came is V is equal to IR. This is Ohm's law. And you can also write I is equal to V upon R, or R is equal to V upon I, whatever you want. So in short, we have three formula, this, and this. And again, I have taught you about the combination, that is series and parallel. In series, for R equivalent unit, if resistances or resistors are connected in series, you just have to add all the resistances, then you will get the R equivalent. Again, if you are going for parallel resistances, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 dash dash dash. This is all we study in this chapter. And in the next topic, we will talk about power and heating effect of current. But before that, I want you all to clear this concept. This is very important to know how we apply the formula, the calculation, and if you will do a lot of practice on this question, on this formula, it will be very easy. So I'm going to give some more questions. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of resistance. Find the value of the resistance of resistor. So we have given, just focus on what is given and then see what we need to calculate and apply the formula according to the question. You will get your answer. Please do it. Done.
Sir, 4800 ohm.
Is it 4800?
Yes, sir.
Okay, I'll check it out. Abdullah,
4800, sir.
4800. Okay. Wait a minute. Oh, that's good. The resistance is basically 4800 ohm. And if I want to convert it into kilo ohm, can you do it?
Sir,
This is very
4.8.
4.8. What we have to do is just divide it by 1000, and it will be converted into 48 by 10 ohm, kilo ohm, or it will be equal to 4.8 kilo ohm. Very good, both of you. Another questions for you. This is also very easy question. A battery of 9 volt, please write with me, is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm, and 12 ohm. How much current would flow through the 12 ohm resistor? Please do it. Can you do it, Harsha and Abdullah?
Sir, 0.75 ampere.
0.75 ampere. What is the total resistance you have calculated, Harsha?
Sir, it only asked about the current through 12 ampere rate. 12 ohm rate.
But you know that current in the series are same. Yes or no?
Yes, sir.
So we just have to find out equivalent resistance first, then we will calculate.
Okay, sir.
Because with the all resistance, if what you have done, I think, is that V is equal to IR and I is equal to V upon R. So you have just kept the value V that which has 9 and R as 12, right?
Yes, sir.
But this is wrong answer, because if you are going to if there is a question that asked what is the current through 0.5 ampere, what will you do? 9 upon 0.5, right? But we know that in series combination, where there will be another value of I. Just suppose this is I1, this will be I2, but they are in series. That means current flowing through these resistors are same. So in series combination, we need to calculate what is the total resistance, and then we will calculate the current.
So, sir, if we use the formula, it will be wrong.
No, the formula is correct, but the method you have used, just see. I'm going to explain. Abdullah, have you done with this? Your answer, please.
Yes, sir. 0.75.
0.75. So you both, what you have done is V is equal to IR. This formula will be applied. But if you are going to check I is equal to V upon R, this will be 12 by, 9 by 12, and it will be 0.75 ampere. Again, if you are going to apply this formula for 0.5 ampere, it will be 9 by 0.5, which equals to 90 upon 5. If you are going to remove this decimal, it will be here, and 90 by 5. And if you are going to check it, it will be 18 ampere. Is it correct to have different current in series combination?
No, sir.
No, because in series combination, all the resistance are in the same line. So if 18 ampere is going through 0.5 ampere, 0.5 ohm, then through 12 ohm resistor, this 18 ampere will go or not? Are you getting my point,
Yes,
Harsha
sir.
and Abdullah? So what we need to do, this is very important to know that, note that this is all given. A battery of 9 volt is connected in series with resistors of 0.2, 0.3 resistors, series with resistors of this. So what we need to do is V is equal to IR, V is equal to IR, and we need to calculate I, right? So first of all, we are going to calculate R equivalent, which is equal to 0.2 plus, this is wrong, 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12, which will be equal to almost 13.4 ohm. Now you are going to apply the formula V is equal to IR, I is equal to V upon R, which means V has a value 9 and this has a value 13.4, and you will get 0.66, which means 0.67 ampere. Okay.
So, sir, when there are a group of resistors, we should find it by first finding R equivalent.
Yes, if they are in series. If they are in parallel, we calculated correct answer. If they are in parallel, because in parallel, potential difference is same, but what we do is potential difference is same, current is different. Okay.
Okay, sir.
But in series, potential difference is different, and current is potential in series, potential difference different, current is same. The application is very important. Done with this, both of you?
Yes, sir.
Okay. Another question which is very important, and it is slightly different from the previous question. How many 176 ohm resistor in parallel? This is given in the question. If 176 ohms of resistors, you have many resistors of 176 ohm, and you are going to arrange it in parallel, are required to carry 5 ampere on a 220 volt line. So it is given that the current producing in the circuit is 5 ampere, which has a potential difference which is 220 volt, and there are resistors of 176 ohm. How many 176 ohm resistors are connected in parallel to give this much current on 220 volt. Can you do this or not?
Sir, I'll try.
Okay, just try it and let me know if you are unable to solve.
Sir, can you explain?
Okay, no problem at all. See, uh, just let the total number of, we need to tell how many 176 resistors are arranged in parallel so that it will give 5 ampere on a 220 volt. Let the number of total number of resistors be X. We are going to take X. Current, it is given as 5 ampere and the potential difference, which is 220 volt. From this, we can calculate the R equivalent. Resistance R equivalent, we can apply the formula V is equal to IR, and R equivalent will be equal to V upon I, which is equal to V has a value 220 and I has a value 5, which means 5 4 5 4, that means 44 ohm. 44 ohm is the equivalent resistance. This is equivalent resistance in parallel, equivalent resistance. Because when we apply this formula, V is equal to IR, R is basically the total resistance. Now, this is the R equivalent, and since it is in parallel, we are going to apply the formula. We don't know how many resistances are there because it is asked in the question. 1 upon R equivalent will be equal to 1 upon R plus 1 upon R2 plus 1 upon R3, and all the resistances are of 176 ohm. So I am taking it RRR because all the resistors have a value 176. This plus dot 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 X times, because we just took it X resistors are there. That's why it is X times. Now see, 1 upon R equivalent has a value. How many value? What is the value of R equivalent? That is the value of 44. Now, if it is X times, it will be X upon R or not. If it is 2 times, it will be 2 upon R because LCMs will be same. R has the same value. Yes or no, Harsha?
Yes, sir.
Abdullah?
Yes, sir.
Now see, 1 upon 44 is equal to X upon R. And R has a value that is 176. And now you can calculate X will have value 176 upon 44, and it will be cancelled by 4. So total 4 resistors of 176 ohm will be arranged in parallel to give a current of 5 ampere on a 220 volt line. Please write it.
Sir, why would it be x by r?
X by r. Just see, if I am going to write it three times, 1 upon r plus 1 upon two times, what it will be? You will take LCM r and it will be 1 plus 1. So it will be 2 by r, right? Yes or no?
Yes, sir.
If it will be three times, 1 upon r plus 1 upon r plus 1 upon r, what it will be? 3 by r or not?
Yes, sir.
If it will be five times, 1 by r plus 1 by r plus 5 times, then 5 by r. Yes or no?
Yes, sir.
So if the total number of registers is x, just suppose x times the registers, then it will be add it will be adding x times, then it will be x by r or not.
So, sir, 1 by r into x. No?
Yes, 1 by r into x you can do, or basically in number it is very easy to understand. If it is 10 times, then what will you do? 1 by r plus 1 by r 10 times you will do, or what you will do? 1 by r into 10, 10 by r.
Yes, sir.
So in the same way, x is what? Alphabet. So x into 1 by r you can say, and x by r it is.
Okay, sir.
Okay, please let me know if you are done with this. Abdullah, do you have any doubt in this?
No, sir.
So can I change the slide?
Sir, just
Yes,
one
sir.
minute.
Okay, okay. Harsha, please write it and then I will give you another question.
Done, sir.
Okay, very good. So how many? So, wait a minute. So how you would connect three register each of resistance 6 ohm, so that the combination has a resistance, that means equivalent resistance. First one 9 ohm, second one 4 ohm. It's very easy. You just need to have a heat and trial method. 6 ohm resistors, we have three: 6 ohm, 6 ohm, 6 ohm. And how we are going to connect it, whether in series, parallel, or both together, to get a equivalent resistance of 9 ohm or 4 ohm. Please think about it, solve it, and then you will get your answer. Done. Can you solve it?
Sir, can you explain?
Okay, just see, this is basically hit and trial method. So you can see 6 ohm, 6 ohm, 6 ohm, three resistors are there, and we are going to have a equivalent resistance with this three resistor of 9 ohm first. So if you are going to put all these three resistance in series, sorry, in parallel, then you have to know one thing which is very important. If you have individual resistances, if you have more resistors and you are going to calculate that resistors in parallel, the equivalent resistance will be value lower than the smallest individual one. Is that clear, Harsha?
Yes, sir.
So if you are going to 1 upon R equivalent, 1 by 6 plus 1 by 6 plus 1 by 6, it will be basically 6 LCM 1 plus 1, that will be equal to 3 by 6. And if you are going to find the value R equivalent 6 by 3, that is equal to 2 ohm. But this is wrong because we need to have 9 ohm. So what I'm going to do is put two resistances in parallel and one resistance is in series. So here how it will look like, it will be looking like this. Now, can you please solve the value equivalent resistance for this?
Yes, sir.
So please solve it and let me know.
Sir, 9 ohm.
9 ohm. Very good. If you are going to solve this, it will be like 1 by 6 plus 1 by 6, that will be equal to 2 by 6. And this is the value of R 1 upon R equivalent. So it will be R equivalent will have a value 3 ohm. And with 3 ohm, this 6 ohm will be in series. So the equivalent resistances will be 9 ohm. So, Abdullah, is that clear?
Yes, sir.
Now see, what we are going to do is two resistances in series and one resistance in parallel. Please solve it. This is the second. Please solve it.
Sir, 4 ohm.
4 ohm. So you can see 6 plus 6, it will be 12 ohm. And with 12 ohm, this 6 ohm is in parallel. So it will be 1 upon R equivalent is equal to 1 by 6 plus 1 by 12. So if we have a LCM, that is 12. So 2 plus 1 and 1 upon R equivalent is equal to 3 by 4. Sorry, 3 by 12. And we have a value R equivalent is equal to 12 by 3. So it will have 4 ohm. Is that clear, both of you?
Yes, sir.
So we are
Yes,
going to
sir.
learn next concept in the next class, like heating effect of current. Please read about it. Heating effect of current and power. Okay.
Sir, I have a doubt.
Okay. Ask me.
Sir, then how will we know when to divide it in parallel and series?
When to divide it in parallel? Like this question.
Yes, sir.
So basically, Harsha, you have to do hit and trial method. Like when you will do a lot of practice, you would know that if 6 ohm, 6 ohm, 6 ohm, when you take it in series, it will be like 18 ohm, right?
Yes, sir.
So just hit and trial. You have to put 2 ohm or 1 ohm in parallel with two series, and you will get your answer. There is no shortcut. You just have to calculate in mind so that you will get your answer as soon as you can think about it.
Okay, sir.
Okay. Or you can do a lot of practice from other books.